And what about their nitrate salts? What about their nitrate salts? Their triazonitrate 5 salts, trioxo. And I believe you know these 4, 5, 3 we've been mentioning are oxidation numbers. We talked about oxidation numbers on our lecture on oxidation and reduction. So you can determine the oxidation number of any atom in a compound following a set of guidelines, right? So here you have their triazonitrates, 5 salts, decompose upon heating. So those ones are in existence. Decompose upon heating to produce the oxide of the metal, metallic oxide, to produce the metallic oxide, comma, to produce nitrogen 4 oxide. Now you can see group 2 elements produce nitrogen 2 oxide. Group 1 didn't even produce nitrogen 4 oxide at all. Group 3 produced nitrogen 4. You can see the gradual trend, all right, in terms of reactivity, because group 3 are the weakest, so they produce nitrogen 4 oxide, they even give off oxygen gas. Group 2 are relatively stronger than group 3 in terms of reactivity, and as a result, instead of producing nitrogen 4 oxide, they gave nitrogen 2 oxide instead. While group 1 didn't even give nitrogen 4 oxide. I mean, they're triazonitrate 5 salts now upon decomposition. So it's a gradual trend. Now, to produce the metallic oxide, nitrogen 4 oxide, and liberates oxygen gas. And liberates oxygen. So how do we back that up? If you have aluminium nitrates, AlNO33, we told you how we came about all these subscripts, right? Upon decomposition, gives you the oxide of the metal, which is the metal here is aluminium, and that is the oxide of it. It gives you nitrogen 4 oxide gas, and it gives off oxygen gas as a byproduct. Al2O3 should be solid, since there is no water present in the equation at all. This is gas, and that is gas. So how do we balance this? We have 2 atoms of aluminium on the product side, so we need to introduce 2 here, giving us a total of 6 nitrogen atoms. 6 nitrogen atoms, and a total of 18 oxygen atoms. So here we have 12 plus 3, right, 15. 15 plus 2 is 17. So oxygen is not balanced. And how do we balance oxygen? We need 3 more oxygen atoms to the Al2O3 and NO2 compounds, right? We already discussed balancing of chemical compound in atomic structure. So when we talked about atoms, molecules, and ions. So to balance this, you just multiply it by 1.5, all right? So this gives you 12 plus 3, 15 plus 3, right? And then, we don't deal with fractions in chemical equations, so we multiply all through by 2. Multiplying all through by 2 here, you have 4AlNO33. You have 2Al2O3. We have 12NO2. And we have 3O2. So the equation now is balanced. And that's how you balance their equations. Okay. So guys, before rounding off, let's take one more point. It is super important. I almost forgot. Now, group 3 elements are used for an industrial process we call doping, right? So they are used for doping, or for doping processes. Now, doping has been discussed in our lecture on semiconductors, right? When you talk about doping, semiconductors, like we said, remember we talked about group 3 elements being partly metallic and partly semi-metallic. So because they are semi-metallic means they are used as semiconductors. And one of the unique features of semiconductors is that in the presence of impurities, right, the conductivity of semiconductors increase, right? They are weird conductors. Their conductivity increase with temperature, their conductivity increase with impurities, and some other bizarre factors like that. Now, if a neutral semiconductor should be a group 4 metal, semi-metal, sorry. That's a neutral semiconductor is a group 4 semi-metal. But if you look at the conductivity of semiconductors, their conducting units are electrons and holes. That means the electricity carriers are electrons and holes. So because group 3 elements have 3 valence electrons, right, they can be used to dope tetravalent semiconductors. Now, of course, you know, group 3 semiconductors have 3 valence electrons, right, which means they are trivalent, right? Tetravalent means they have 4 outermost electrons. Now, if you want to reduce the number of electrons in that conductor such that you allow for more holes than electrons, you can dope you can introduce group 3 elements into the tetravalent semiconductors. You produce something like an alloy, right? You blend the group 4 conductors with group 3, okay? And that process is called doping. And what are you doping with? You're doping with a trivalent metal. Usually we use gallium, we use boron sometimes, all right, for doping. And what happens is they are used to form a p-type semiconductor. And why is it called a p-type semiconductor? It's called a positive type semiconductor because now you have increased the number of holes in that tetravalent conductor by 1. Hence, there's less electrons than holes. You know electrons are negatively charged, right? So if you have lesser number of electrons, it means you have a net positive charge. The details of this has been given in semiconductors lecture. Now, we're introducing this here because group 3 elements are used for doping, especially gallium. So gallium is added to a tetravalent semiconductor to improve its performance. Hence, you turn that tetravalent semiconductor to a p-type semiconductor by increasing the number of holes you have. And how do you increase the number of holes you have? You can't directly increase the number of holes, but you can reduce the number of electrons, right, by using a trivalent metal. So reducing the number of electrons invariably increases the number of holes because you have a net positive charge. And that's why we call it the p-type semiconductors. So if we put that into writing, we call this, they are used for doping processes, right? Processes to form p-type, semiconductors. To form p-type semiconductors. Very important. Very important. So guys, that's it about group 3 elements. I hope it made sense. I hope you enjoyed it and I hope you learned it. You can look up for more points, for more characteristics of group 3, but I assure you if you will be tested in WAEC and JAM levels for group 3 elements of a periodic table, we probably in one way or the other would have mentioned it in our videos. So do well to continue watching our videos and always make sure you watch these videos to the very end because there's a lot of information for you to imbibe. In the next lecture, we'll move to group 4 family, all right, the group 4 of the periodic table. So thank you for sticking with us and see you in our next lecture.